So hello everyone, in this video we will solve another leet code question, that is sum of all subset XOR totals. So let us read the problem statement. So the XOR total of an array is defined as the bitwise XOR of all its elements or 0 if the array is empty. For example, the XOR total of the array 256 is 2 XOR 5 XOR 6, that is equal to 1. Now you are given an array nums and we need to return the sum of all XOR totals of every subset of nums. Now the subset with the same element should be counted multiple times, and an array is a subset of an array B if A can be obtained from B by deleting some or possibly 0 elements from B. So this is the definition of subset they have given. So what the question is saying, that we need to first take all the subsets of an array A. In this case we have given array nums, so we need to take all the subsets of nums, and for each and every subset we need to take its XOR of each and every element. After taking the XOR, we need to add it to our sum, the resulting sum. Now for each and every subset we need to do this thing, and in the end we need to return the total sum of all the subsets. So let us see this second example and try to understand what the question is saying and how we can derive a solution out of it. But before moving to that, one thing we need to keep in mind is that num's length can be as max as 12 and nums of i's can be as big as 20. So this will help us to derive to a particular solution. So this is the second example and let us see how we can derive a solution out of it. So first of all, the basic thing to notice is that we need to have subset of of this entire array nums. So first let us derive all the subsets possible for this particular array nums. So one can be an empty subset with no elements. One can be the individual elements like 5 alone, 1 alone and 6 alone. So these are another subsets. Then other subsets can be 5, 1, 1, 6 and 5, 6. So these are the subsets which contain 2 elements together. So and the last one is the all elements together, that is 5, 1, 6. So these are all 8 possible subsets, but we don't need to take care of this because it is an empty subset. So the XOR is nothing, it's 0 only, so it will not add up to our answer. So we don't need to count this empty subset. So this is what we need to derive first. First we need to take all the subsets. Now after getting all the subsets, we need to take XOR of individual element. Let's say its XOR is XOR 1, its XOR is XOR 2, and so on and so forth. We have XOR 3, XOR 4, XOR 5, XOR 6 and XOR 7. Now what is this XOR 6, XOR 7? So XOR 1 is XOR of all elements within this subset. XOR 5 is XOR of all elements within this subset. Now what we need to return is, in the end we need to return the sum of all these XORs. So our sum will be XOR 1 plus XOR 2 plus XOR 3 and so on up till XOR 7. So this is what we need to return, the sum of all the XOR of each and every subset. So this is pretty straightforward question, and one thing I told you before is the size of the array can be as max as 12. So this is the clear idea of using a backtracking solution to get all the subset, because we already know that we can derive subsets or we can get subset of an array nums using backtracking or recursion. In this case we are using backtracking, and the backtracking best example is like the getting the constraints. It can be like, it is here given the size of nums array can be as big as 12. So our backtracking solution will perfectly work. It will not give us the TLE because constraints are very small. So that's why I told you to keep the constraints in mind before we dive onto the solution. So one thing is for sure, that we will use backtracking for deriving the subsets, and then in the end it's simple. We take individual XOR of each and every subset and keep on adding to our answer. Now the question is how we will use the backtracking to get each and every subset. So let us see that first. So let me erase this. So we have seen that how we have derived this subset. So we have these three elements. So at each and every point we have one option. Either we can take that element or we not take that element. We not take. If we take 5 and if we not take 1 and 6, so it is one particular subset, and it was in our example also that we have seen. Now the second is the like if we are on 1, we have option either we can take 1 or not. So the first case is over. Like if we are on 5, let me iterate it over and explain in a better way. So let me redraw this. So let's say I am on 5 currently and I am moving with the help of 5. So I have two options. Either I can take 5 or not take 5. Let's say I have taken 5. Now I pointer will be pointing to 1. I have again one option. I have two options. Either I can take 1 or not take 1. So I decided to not take 1. Then my I pointer will be over here to 6. Again I have two options. Either I can take this 6 or not take this 6. I decided to not take this 6. Now our I pointer will be reach to the end of the array. Now this is the base condition that we need to stop and store the subset that we got till now. So I only got 5 as my subset, so I will store it in my answer. So this is one particular subset. Now I will again start iterating from 5 again. So my pointer is again on 5. I have two options. Either I can take 5 or not take 5. I decided to not take 5. Then I am on 1. So I have again two options. Either can take it or not take it. I have decided to take this element. So I have taken 1. Now I am 6. I decided to not take it. So I have another subset with only one element, and that is 1. Now I'll again start iterating. So I'm not again and again iterating. I am using a backtracking. So it keep on like going back and doing something else. Like it will take some other condition of not take or take. Then it will again backtrack. So it will keep on happening. We will see in the code. So I'll again start. So let us take one example where we have two elements in our subset. So I am on 5. I have two options. Either I can take it or not take it. I decided to take this element 5 and I move on to this one. I decided to not take it. Then I am on 6. I decided to take this element. So I take this element and then I reach the end of the array. So after reaching the end, that means we got one particular subset. So we stored this in our answer. So we keep on doing until we like exhaust with all the conditions and we have made all the subset possible. So this is how we will do it. So we just need to look at two conditions. Let's say we are having a solve function that will help us do the backtracking. So one condition can be of like not take, and one condition can be of take. So in not take condition, we will just increment our I pointer. Let's say I am using backtracking with the help of this solve function. So I just need to increment our I pointer. Now in the else case where I am taking the element, so first I need to push that particular element into my subset. So I'll push that element. So res dot push. Let's say I am storing the subset in this res array or res vector. So nums of I push that and then I'll move forward. So after pushing it, then I'll move forward. And what is the base condition? Base condition is nothing but if our I becomes greater than equal to nums dot size. So then we need to return because there are no more elements further and we got one particular subset. So this is one base condition. So with the help of this backtracking approach, we will get all the subsets. And in the end, what we need to do, this is not the end of the question. We just not need to like derive the subsets. We need to take the XOR of each and every subset and add it to our answer. So let's say like I have stored all my subsets in one particular like 2D matrix or something like that. So I have all my subsets. So let's say I have 3 subsets. So I'll go to at each and every individual subset and I'll take XOR of each and every subset. Now after taking XOR, I'll maintain one sum variable and add this XOR to my answer, which is nothing but sum. So I'll keep on doing until we take each and every subset into a consideration, and in the end we will return sum. So this is how we will do it. Now let us write the code to understand in more better way. So let us write the code now. So n is the size of nums, and I am declaring a matrix answer which will store all the subsets, and I am also declaring one vector by the name of res which will store the individual subsets. Now what I am doing is I am making a solve function which will do the backtracking for us, and in the end it will return all the subsets in our matrix called answer. So let us first write the solve function and see what we will do it after that. So in the solve function we need the nums, we need the pointer to move in our nums vector or nums array. So we'll start with index 0, and we will have one res and we will have one answer. So these are all the parameters. Now it will be a void function because we are just adding it to our answer, our answer matrix. We are just adding subset to our answer matrix. We are not returning something. So it is a void function, and let us pass the parameters. We'll move with the help of I pointer, and vector of int ans. So what was the base condition? We need to first write the base condition. So the base condition was that if I is greater than equal to nums dot size. So if our I is greater than equal to nums dot size, so what we need to do? We just need to simply return no. First we need to add that particular subset to our answer matrix. So we will add that subset to our answer matrix. Now what is that subset? That subset is stored in res vector. So we will push that res vector to our answer. And then we will return. Now what are the two conditions? Not take and take. So first we'll write the not take condition. So what was the not take condition? Simply we just need to move one pointer ahead without taking any element. So we'll just increment our I pointer and we'll write the parameter as it is. Now what is the take condition? The take condition is first push the current value or current particular number to our res vector. So what is the current number? Nums of I. So we'll push that into our res vector. Now after pushing, then we will go to further elements. Solve nums comma I plus 1 comma res comma ans. So what we are doing, it is the base condition. After we reach the end of the array, we need to push that subset to our answer. Now we have two conditions, either we don't take that element or we take that element. If we are not taking that element, just simply move to further recursion calls. Otherwise first push that element to our res vector and then make the further calls for recursion. So this is how we will do it. Now we got the entire subsets, all the subsets stored in our answer. Now we need to take the sum of all the particular subsets and return the sum of all these subset of XOR subset of and store it in some variable and return that sum. So let us say we are using a sum variable to have the sum of all the XOR of each and every subset. So we will move to each and every subset. So we'll keep one x variable which will store the XOR of each and every subset, and then we are moving to each and every subset. So int j equal to 0 to j less than ans of I dot size j plus plus, and we are taking XOR. So x XOR the current element is ans of I comma j. Now after taking the XOR of that subset, we need to add that XOR to our answer. So we will store, not store, we will need to sum that to our sum variable. So we will like sum that XOR and add it to our answer. So we will add x to our sum. Now this will keep on happening for each and every subset, and in the end we will return this sum. So what we are doing, first we are getting all these subsets, and how we are getting all these subsets I already told. Now after getting all the subset, we are going to each and every individual subset. Now for each and every individual subset, we are taking the XOR of the entire subset. After taking the XOR, we are adding that XOR to our sum variable, and we are keep on doing for each and every subset, and in the end we are returning that sum. So let us see if that code works or not on sample test case. So yeah, it works on sample test case. Let us try to submit that. So yeah, our code got accepted. Hope you learned from this video. Thank you.